Hey everybody, welcome to Chapter 4, Section 4, Proving Triangles Congruent with SSS and SAS. That stands for side, 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 and side, angle, side. So basically in the previous video, we used the corresponding parts of congruent triangles are congruent. So we looked at every single part of the triangle and we were like, yeah, all these sides are congruent, all the angles are congruent, so therefore the triangles are congruent. Well, these properties are defined that if you know that all three sides, side, 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 are congruent to one another, therefore you can conclude that those two triangles are congruent to one another. And then moving on to the SAS, I'll get to that later in the video. I'll start with side, side, side first. But SAS will say the same thing. If you know a side, angle, and side are congruent, then you know that those two triangles are congruent. So that's basically what's going on here. So we will be doing some proofs in this video. I'll do my best to explain them as logically and smoothly as possible. But yeah, so I've already defined out the side, side, side congruence here. And so let's just jump into our first example here, and we'll try and use that side, side, side theorem on this example. So given that GH is congruent to KJ and HL is congruent to JL and L is the midpoint of GK, prove that triangle GHL is congruent to triangle KJL. So nothing's marked on this image, so if that ever happens, I like to take what's given and I like to mark it there. Okay, so the ones with one dash are congruent to each other, the ones with two dashes are congruent to each other, and then I just put a dot right there for L because it says it's the midpoint of GK. So, first statement, GH is congruent to KJ. That is a given statement. And then if you notice, my second reason is also given. So what's also given to us? Let's talk about this side. So HL is going to be congruent to JL. And then the third thing it says is L is the midpoint of GK. Gee, how do we know that? Well, that's also given. So clearly we've been given a lot of information here. The next proof says midpoint theorem. So you don't have to know the exact definition of the midpoint theorem. You just got to understand what it means. I know that if something is the midpoint, it's going to create two equal segments, right? So basically it's going to say that GL is going to be congruent to LK because L falls directly in the middle of those two. So that's what we're going to say next right here. We're going to say GL is congruent to LK. And so if we zoom back out here, we've established that all three sides are congruent to one another. So we can conclude now that the two triangles are congruent to one another. And then our proof or our reason is that it's the side, side, side congruency. So I'll just put SSS to keep it short. But yeah, that proof is done now. So let's move on to example 2. So example 2 is going to deal with the side angle side congruence postulate. And so the side angle side, it's not just any side angle side. The angle has to go in between the two sides that are marked. So like see how it says like a mark here. So we'll call that side, angle, side, right? If the angle, so let's say these two sides were marked, and if angle C were marked, it would go side, angle, and then it's blank before it gets to the other side. That would not be side angle side congruency. So it doesn't kind of matter. It definitely matters where that angle is marked. It has to fall in between the two marked sides, okay? So I hope that makes sense. So let's do this example 2. The scaffolding for stage lighting shown appears to be made up of congruent angles. If WX is congruent to YZ and WX is parallel to ZY, write a two-column proof to prove that triangle WXZ is congruent to YZX. So let's see here. So WX is congruent to YZ. So WX is this one up the top, and then YZ is this one at the bottom. And then it also said that these lines are parallel. So I'm going to draw an arrow. Okay, so that's, going to be good enough. So we know that these lines are parallel and that the top line is congruent to the bottom line. All right, so the first thing that is mentioned in the statements is that WX is congruent to YZ. So that is given to us. And then if you notice, the second reason is also given. So what else is given to us? That WX is parallel to ZY. And so you might be thinking, why is it relevant that these lines are parallel? Well, remember, parallel lines with a transversal that goes through them, you got to remember your previous units here, create, alternate interior angles that are congruent. So like this angle here would be congruent to this angle, and this angle here would be congruent to this angle. And there are other things that it says, like alternate exterior angles are congruent, corresponding angles are congruent, consecutive interior angles are supplementary. It says all that just by giving us a parallel line and then a transversal. This will be our transversal going through it. Okay, so the next proof says alternate interior angles theorem. So let's see here. We're trying to use side angle side congruency, right? So if this is my side, then this needs to be the angle that comes next, that or this one here. But you got to think, then I'd have to use this side for my congruency statement or to prove next. And so look, this side is shared by both triangles, so that's very easy to prove if it's shared. So I'm going to say that this angle right here is congruent to this angle right there. And those are alternate interior angles. So I just need to give those angles a name. So it looks like it's going to be angle WXZ. And then this one down here will be XZY. Okay, so we've established that a side and an angle are congruent to one another. Now we just need to establish that, hey, this third thing, I was going to say third side, but it's not the third side. It's side, angle, and then the side is congruent. So how do we know that? Well, what side is this? This is ZX, and then what side is it on the other triangle? ZX. That's your reflexive property of congruency. And remember, you could have also said XC is congruent to XC. The order doesn't really matter. But yeah, there you see that for the proof it says reflexive property. So we just used the side angle side congruency to prove that these two triangles are congruent. So this last proof line, I'm going to write side angle side. So that's going to be it for example 2. So let's move on to example 3. So example 3 says determine whether or not the triangles below can be proved congruent. If not congruent, explain why. So here I have this triangle. Clearly all three sides are marked as congruent. So this one would be yes because of side, side, side. Okay, so let's move on to the next example. Excuse me. So this one here has a side marked, and then they're sharing this one, so you can conclude that the shared side is congruent. But that's only pointing out two of the sides. None of the angles are marked as congruent. And so if you don't know that those angles are congruent, then this is not enough information. So I just wrote not possible because SS is not a thing. All right, so let's see here. This one has a side angle and a side marked as congruent, but like I said before, the order matters. So you see how the two sides are marked? That means this angle here needs to be marked as congruent. So right now this said side angle or angle side. So SSA or ASS, yes, I just spelled ASS, are not a thing. So it's either SAS or that's all it can be, SAS. You can't change the order of it. So there we go. I just wrote not possible because SSA or ASS is not a thing. Once again, I'm just saying ASS. I'm speaking about geometry terms. I'm talking about angles and sides. You're the one being immature about it. So, last one. It goes side, angle, side, or side, angle, side, side, angle, side. So that one's good. Yes, you know it's congruent because of SAS. So, yeah, that's going to wrap it up for the video. Thank you for watching. Hope you learned something, and goodbye.